Hello everyone, welcome to Google Cloud OnAir live webinar from Google Cloud, and we are hosting webinar sessions every Tuesday. My name is Mongran He, and this is my colleague Harish. Today we will be talking about how Credit Karma improved the working efficiency at scale by using the Google BigQuery and Looker dashboard. You can ask a question anytime on the platform, and we have Googlers stand by to answer at them. Let's get started. I'm marketing analyst at Credit Karma, and this is Harish Gaga.
Hi, this is Harish Gaga. I'm a staff BI analyst at Credit Karma.
Let me introduce Credit Karma for a minute. So Credit Karma is a financial technology company founded in 2007, best known for providing credit score for free for our 18 million members. And we can always provide the data-driven insights and identify the opportunities for our members and make the most of their money. Whether someone is interested in getting a better deal on the loan, like the credit card or mortgage, or simply just need to monitor their identity or credit information, we can always provide the actionable tools for them and help them make their financial progress. Some quick stats about Credit Karma. As I just mentioned, we have more than 18 million members in the US and Canada. With that being said, if Credit Karma was a country, it would be the 16th largest country in the world, which is ahead of Germany. And there's around $40 billion of credit originated through Credit Karma over the last 10 years. That's bigger than the GDP of Kenya, Jordan, and Iceland. And there are around 20 million Americans who have applied for a product like credit card offers on Credit Karma platform. That's more people than were born in the US over the last 5 years. And there's around half of the US millennials use Credit Karma app. That's more than the number of millennials who watch Hulu or Amazon Prime. As I mentioned, Credit Karma is a highly data-driven company. We can always provide the actionable tools and help our members to make their financial progress. So Harish, would you please introduce what data infrastructure looked like in the past and nowadays at Credit Karma?
Absolutely. Thanks, Megran. So before 2016, we had an in-house columnar database, and team was spending a lot of time in terms of scalability and performance tuning. Scalability in terms of they were keep changing the dashboard database configurations to support our database needs, and they were also spending a lot of time in hardware maintenance and also the expensive license renewal. And on the performance tuning side, the queries performance was really slow because most of them are coming from the complex join on the columnar database, and it's delaying overall our ETL processing time. And analytics team were waiting for a long time to see the up-to-date data. So we ran with a lot of the POC, and finally, we found that BigQuery was the best database for us to support our business needs. So let me cover how our data stack looks like now. So from 2016, Credit Karma data stack growth from 30 terabytes and to the 1.8 petabytes, and we collect 9 terabytes of data every day, and we run many model prediction also. So this is all about volume, but also we build many API jobs which able to connect the various different sources. For example, we are connecting Salesforce for finance data, and we connecting Facebook for media and Google AdWords for marketing ads. And like that, there are other API jobs too, which we run on every day and land into the BigQuery and do our Looker reporting on that. On the other side of the other type of jobs, which is like mostly the machine learning models that we're also running on the BigQuery. So we, for example, if you want to forecast our daily active users, and if you want to forecast like how many email we want to send and what kind of offer we want to send, and if you want to predict our scoring rates, so all these different models also we are running. So I would like to thank Google and their entire support team who really helped us to brought to this position, and this also help us in our day-to-day business value. Now we have like 3 different use cases, which is talk more about how we leverage a BigQuery on our day-to-day life. So first use case is daily active user forecast. I will let Megran to drive this one.
Thanks, Harish. So let me define daily active user for a second. So daily active user is a metric to measure the number of members who come to our site every day. And it can be reflected by the way we connect with our members and also measured by the product performance. So a better daily active user forecast model would allow our stakeholders to monitor the product performance in a very prompt way. And we use Google BigQuery database to store the model input and also the forecast result, and then migrate the result from the BigQuery database to Looker dashboard, so that our stakeholders can monitor the performance and then compare against the actual daily active user on the dashboard directly. So in this way, they can improve the speed and quality of their business decision for engaging with our active users. Prior to the current improved data infrastructure and the pipeline, we have to train the model manually every time we launch the new initiatives. So it costs a long turnaround time for adjusting those impact of the new initiatives. And also, we have to collect the data from different channel owners or organizations, which means it's hard for us to unify the model input and then produce the output very promptly for our stakeholders. Because the data collection is siloed, it adds up the layer of channel dependency onto the pipeline, and also human error might be involved during the process. So Harish, would you please tell us how business intelligence team at Credit Karma solve those challenges and improve the infrastructure?
Absolutely. We have automated data pipeline system which connect our expected email click ratios and the actual email click ratios, and then we forecast like how actual user is going to perform on the email what we send. On this data pipeline, we use the Airflow, which is an open source tool from the Airbnb. This is like for managing the complex workflows and scheduling the jobs. First thing is I'd like to cover how we drive the expected email click. So in this, our pipeline is first reading the Google spreadsheet. The Google spreadsheet is we are running through Python, and that the Excel sheet is mostly maintained by our campaign managers, where they day-to-day basis they continuously updating our expected email and push notification click volume. Once the Python program runs, it's load the data back to the BigQuery, and then on the other side, we connect back to the BigQuery again for our actual data. So once we have our expected email and push notification data and the actual email and push notification data, we combine both this data and prepare our data set for the model. Then we send this data back to our machine learning model, and that machine learning model trying to predict the daily users, how they're going to take an email, how they're going to read those emails, how they're going to perform over those emails, right? And then we send this forecast number back to the BigQuery, and ultimately then we connect this Looker to the BigQuery to see the overall performance on our daily forecast.
Thanks, Harish. So because of those improvements on the data pipeline, we got the chance to improve the flexibility and the robustness of our forecast model, just like the daily active user forecast. And also our stakeholders can get a better and up-to-date report directly on the Looker dashboard for their business planning. And they also can monitor the product and the channel performance on the Looker dashboard directly, and it improves the working efficiency a lot. And next, Harish will talk about how Credit Karma uses the machine learning tools to improve the email targeting efficiency.
Yes, thanks, Megran. So we are trying here. We are like in this particular use case, we are trying to improve the overall the targeting efficiency on the email notification. So before I proceed on the remaining slide, let me talk more about what is model-driven email is. Model-driven email is a machine learning model where especially we are looking for what kind of offer users are searching. For example, if they are looking for credit card or personal loan or mortgage loan, so based on the requirement, we predict we predict the users who most likely tend to get those emails and who also likely to open those emails and click on those emails and then take the offer from us. I will cover the data pipeline more in detail, but I want to first explain what are the challenges we had before. So these are the couple of points here. Like we have huge amount of variables to support. So we have 80 million plus members, and there are like 1,000 plus input variable. It was very difficult to and it was very time consuming and resource intensive too, to collect all this data collection, and then send those data back to the model and then score and then send it to users. It was almost a nightmare for us to run those huge amount of data on the columnar database, and there was no manual check, and there were no quality checks also in place, and we don't know like what are the data anomaly we found over those emails and variables, right? Many variables are coming with a blank values, or they don't have any values. So there was no point in running model on such values. So it was very difficult to identify such problem without an automated pipeline system. I will talk more about like how we solve those challenges. We use the Airflow to implement such end-to-end pipeline. This pipeline is help us to collect the data over all the users who perform on the emails in the last few months, and we collect all those data, run a scoring, and then finally send out an email. So let me start with a little bit more detail at how this pipeline works. This pipeline is actually works on the three models. One is the impression to click. That means that when we send out an email to our users, when they saw the email and they click on that email, that means impression to click. And the second model is click to applications. When they try to click on the offers, and they try to fill all their information on the partner side and then submit an application. And the third model is approval. Once they submit an application, their application sent to our partners, and then partners make a decision whether they get approval on their offers or not. So we, in the first step in the Google BigQuery, we try to collect all these three model data. So for impression to click and a click to application, we collect those data points from the user recent monetization history, like how they perform over the email in the past few months. And for the approval model, we rely on our online recommendation system team, where they given us more idea about what are the approval odds for our members. So once we collect all this three model data set, we run the queries, and then we store the data into the Google Cloud Storage. That is for preparing the training data set. Then once that data set is ready, we send those data back to the TensorFlow. So TensorFlow is helping us on this is another like the cloud service we get from the Google, where like we able to run our machine learning model on all these three data sets. So this model is actually scoring the every members on the thousands of variables, just to make sure that we make a right ranking on every members, that what offers they're supposed to receive. So this scoring is calculated entirely through this model, and again store it back to the BigQuery. So once we have our scoring set ready, now we want to drive this scoring, and now we want to drive this our scoring data set through the Excel sheet. So this Excel sheet is all about the campaign sheet. Here we maintain the different email campaigns. So our campaign managers come in and they keep adding the new campaigns, and they modifying the existing campaigns, and they change the behavior of this campaign. That means, for example, if I want to send out an email to the users who have a score between 600 to 700 with the age band of 30 to 35. So they change those criteria, and they look for that what offer we need to send to those users. So they select all those criteria over those Excel sheet. Our pipeline would automatically read this Excel sheet and combine this scoring data set together, and then we run our targeting queries in the BigQuery. So this targeting queries are all about figure it out like who are eligible for sending out an email. So once we have this targeting queries ready, then we send this data back to the Hermes. Hermes is an internal tool which allow us to send out an email to our members with their specific offer needs.
And Harish, would you please introduce what Hermes is at Credit Karma and how we utilize Hermes to send the email to our targeting users?
Great question. So Hermes is an internal tool for the user level targeting, where we can allow marketing analysts to write their own SQL query and decide the range of the users whom they want to send an email and what kind of offer they want to filter out.
Thanks, Harish.
Overall, with this data pipeline, it's helped a lot. It's improve, not just improve the overall, like efficiencies, also improve. It help us to send out the right offer to the users. This help us in overall our engagement on the emails, and also it reduce the overall resources to collect the data every time and refresh the data, run the model, and send out up-to-date emails every time. So this whole automated system is reduced a lot of the manpower and also improve the overall data processing time and also add a lot of value to our business. And we also have a looker who pointing to those the email campaigns data where we do the measurement check that how each campaigns are performing. For example, if we send a chase card to the particular members, whether how many members basically open those emails, how many of them click on that, how many of them take the offer from us. So all this we continuously drive on the looker dashboards, and based on that we going back and re-engineering our the entire data, re-engineering our model to make sure that we have right data set and we have right feature set to ensure that we keep delivering the best the email to our members as we can.
This is really helpful because email is one of our most efficient way of targeting our users and also how we engage with our users. Sending the more relevant message with the right amount of frequency are pretty critical to our business. And next, Harish is gonna wrap up our last use case, how we obtained a better model for user acquisition and a better offer pricing on the search media.
Absolutely. So this is one of our another use case where we are trying to improve the overall the user engagement and user experience when they are looking for any offer on the paid search and display media. So we had like this, how this work is, we have a Google return on ad spend algorithm that allow us to bid in auctions at the user level granularity. And this also help us in overall quality of the new user engagement based on their monetizations. So its monetization is all about how user click on the emails in the past and how they took the offers over the Google ads. And ultimately this help us to send a like also it increase the overall efficiency in like sending the overall revenue to the CK and based on our target. So there are, like, before I explain more about how this data pipeline works, how we improve the automated the ad campaigns, the features, let me first explain what are the challenges we had before, why we got the less traffic in the past over our ads, and how we get the flat value on the every transactions. So we had this flat to flat rate concept initially on the every credit card application over ads. This flat to flat value also means that what kind of users as came to the Google and take the offer from us in the past, and this base is also is all about, like, these user sets are coming from different user segment. Like, for example, they are coming with a different score band and age band. They are coming with a specific platform like mobile or web, and then they are coming in the last 7 days or 10 days or any months or not. And it's also about they are coming from the organic or display media or not. So based on this different media searches and based on the overall this mixed traffic, we were defining the average weight on the offers. So this average weight scoring was it was like it was good for the campaign level analytics, but it was not good for the user level scoring. Ultimately, like, we were getting the flat rate for every credit card transactions. That was actually slow down the overall the revenue growth. And we also had a difficulty in identifying the issues in the pipeline. For example, when I talk about in the earlier point how the different user segments come in on the site and they take the offer from us, there was like the issue where data is not normally distributed, and we were not sure that what kind of volumes are coming and how the data is coming, and ultimately we are spending a lot of money on our ad campaigns. So overall it was like impacting our transaction revenue on our credit card applications on the ads. So this is how we solve the challenges. We build the data pipeline which is automatically collect all the user, the history, how they perform over the Google ads. So this is like, for example, if users are coming with a specific segments, so we make sure that we collect all this data set for a few months. So what we did is like, we went ahead in our database in a BigQuery, and then we figure it out like what are the user behaviors are. For example, it's not all about 5 segment, it's also about thousands of variable for that given member, how he actually came to site, at which time he came in, from where he came in, and what kind of offer he was looking for, not just on our website, is also on overall on the media. And we collect all these data points, and then we store them in the Google Cloud storage, and then we run our machine learning model to figure it out, the propensity of buying the offer from us. So once we have this data set ready, we send it back to the Google. The Google AdWords has this own algorithm, the ROAS, which is written on ad spend. That algorithm collect this data set, and that's run their own scoring on those data set, and then it's determined that, hey, this is the users most tends to likely take a offer, this particular offer from our ads. And we ultimately send all this data back to the BigQuery, and then we have a Looker again, which is connecting to the BigQuery and see the overall the performance, like how these things are happening, like what kind of users are coming every day, what kind of offers they are looking for, and where we can improve more. So ultimately this helped us a lot. There was no manual work. We automatically, our BigQuery is automatically executing on a schedule basis. They collect all the data points on the user behavior, and it automatically sent to the Google AdWords. Google AdWords decide their own scoring and target. So it's a good align with our incentive between the BigQuery and the Credit Karma data. And it also, I would say that it helped us it also help us in a way that it's use our proprietary data, and it make our media channel more profitable.
Thanks, Harish, for your amazing presentation. So from analyst perspective, it's really critical and also helpful for us to get a better efficiency by using Google Cloud Platform and the BigQuery as well as Looker dashboard. Just like these 3 examples, we can definitely reduce the turnaround time for generating a forecast model for our stakeholders. And we can get a higher and improve the email targeting efficiency. And we can also get a better click-to-conversion ratio in a very cost-effective way. And I hope you enjoyed this webinar session as much as we did. And stay tuned for the live Q&A, and we will be back in less than a minute. Welcome back. So let's get started with some live questions. So the first one, have you used a cloud data flow for the pipeline as well? Also, are you doing this on a real-time base or a batch process?
Great question. We have not used, we have done the POCs on the data flow, but yeah, this is nothing we have put in production. Mostly we are using the Dataproc and TensorFlow for our pipeline. And yes, and we are also doing a lot of in-house testing on the real-time model building, but currently most of them are on batch processing.
Do you have anything to optimize the performance of BigQuery?
Yeah, it's depend like what kind of query you are running for. If you are using the legacy SQL query, we definitely encourage you to use the standard SQL query and make sure that you keep all your joins in mind. And also depends on at what time you are running those queries. If you are having a limited license and you have the many analytics teams who using the BigQuery at the same time, I would recommend that use those heavy queries in the batch job in the night.
Okay. Next question: how does Looker connect to BigQuery?
Yes, so Looker has a so we can in the Looker we can first define the connection to the BigQuery on their admin. We have full control of connecting to the any database. And then we have LookML feature where you just need to import the BigQuery table and it automatically build the LookML for you. All you need to do is just simply refresh that model and simply drag and drop and start visualizing your data on the BigQuery Live.
Next question, what advice would you give to someone who's starting this process now?
Yes, that comes with a lot of things. For example, depends on what kind of infrastructure you have, what kind of instances you want to run. If you want to run like on a smaller data set, it's fine. You can spin up the small GCP instance and then you can create your small project and then you can start with a limited license and you can continue to go from there. But again, if it is coming to the mid and large scale business, you have to decide again on the architecture side that how many instances you need, how many projects you need, because you ultimately don't want one project to create and everyone want your company to use the same project because of limited concurrent query limit. So you have to split those projects out and decide your the organization numbers, like how many people who are going to run the queries and what kind of queries they're going to run. If you organize it very well, then yeah, of course, this is like a perfect use case where you can continuously use and continue scale your instance over the cloud and keep running your queries.
Next one. So how up to date is the data that can be shown on a Looker dashboard?
So that is also depend on like how you want to refresh the data. If you want to refresh on a schedule basis in the Looker, you can always there is an option where you can create your derived SQL queries and you can set a trigger alert for automatically clear the cache. So in that way, if someone go to the Looker dashboard, it will hit to that LookML behind the scene, it run that query and automatically clear the cache for you and show you up-to-date data. And but sometime like people don't want to create those ad hoc SQL queries because this comes with a lot of performance impact too. So they can always like always go to the Looker dashboard. There is an option there, and you can go ahead and click on that clear cache button, and that will just simply go and hit to the BigQuery table and give you up-to-date data on your dashboard.
Okay, cool. So next question, what made you decide to switch to BigQuery?
Yeah, this is what we something discussed initially, that it depends like from where you are coming from. We came from the columnar database system. They come with a lot of the maintenance issues and also the performance issues because our ETL queries are very heavy and they run terabytes of data every day, and it's really slow down the performance because of the complex join. And ultimately our ETL was delaying and the analytics teams not getting the data on the right time. And also it was a lot of maintenance also, and also cost to the infrastructure also, in terms of licensing renewal. So if you consider all this factor, I mean, Google BigQuery is the place where you can go to the cloud, you can spin the instance so quickly, it's so easy to go there. There are a lot of features rightly available. All you just need to spin the instance, you create your project, and you can always scale that on demand. Basically, you don't need much interaction with any support team or so, because it's so self-explanatory. You can simply go ahead and go to that instance and decide your own query limit, define your own cluster, and start using the database.
Cool. I think that's all the questions we got. So thanks for joining us this webinar session. Please stay tuned for the next session. Google Cloud Internet of Things, from devices to cloud, enabling business outcomes in a secure way. Thank you.
Thank you.